So a little bit ago, I put out a poll asking if people thought trunk lean mass or leg lean mass was the contributor to performance. Ultimately, I asked that because that was a research project I'm working on right now. But turns out, as of 2 days ago, I found a paper that this has already been done. So that's the paper I'll be talking about today. So the purpose of this paper was to investigate the relationship between lean body mass, muscle architecture, and performance in female weightlifters. Ultrasound was used to get cross-sectional area of the muscle bellies of all 4 quadriceps. It's known that cross-sectional area increases with strength, so this paper just kind of explores that. The paper also looks at body composition using DEXA scan. Doesn't actually measure muscle mass, because DEXA only looks at non-fat or non-lipid tissue, so that includes water and tendinous tissue that doesn't have fat in them. So what this paper found was that there was a high correlation to lean body mass, specifically with the trunk, and there was also a high correlation to counter movement jump outputs. This paper talks about how trunk lean mass is correlated to performance, but not as much as the males in another paper that they did in the same year. Correlations were smaller, so I don't really understand what they're trying to get at with that. But I also found that trunk mass had a high correlation to performance as well. So I guess I'm kind of curious as to why that is. The paper also stated that DEXA was the more reliable predictor of performance, so using lean body mass to predict performance than looking at just surface area of the quadricep muscles. Because in weightlifting, size of the muscle doesn't necessarily mean increasing strength all the time. So looking at lean body mass is probably going to be a little bit better of a predictor for performance instead. So this paper looked at counter movement jump and how that affects performance. So we know that counter movement jump can be used as a predictor for lower body power capacity. Now we know this information about lean body mass. You can use any changes that you see in velocity and power production to estimate lean body mass hypertrophy, and then any changes in power that can be used to kind of estimate cross-sectional area. Not only can counter movement jump be used as a tool to monitor performance capacity, it can be used to monitor potential hypertrophy as well. But yeah, that's it.